Well, in this video, I put a little bit more effort into some more advanced techniques, and these are not in the book. So what we're going to do is actually take a transportation problem and add the ability to turn on and off our sources of supply. So this actually becomes a source of supply combined with a transportation problem. And it's called a facility location problem. And this example is not in the book, but here's the data. And it's similar to what we had before. We've got 5 locations where we ship from, and these are the capacity that we're shipping from. It's a single product. And then we've got 6 locations we ship to. And this is the cost to ship from place to place. So places that are really close together, like Cheyenne and Denver, the cost is cheaper. And places that are very far away, like Baltimore, Maryland, to probably Portland, Oregon, is very expensive. So the trick is we want to pick places to ship to these places that are the cheapest, but also these places don't exist yet. So we have to decide which of these 5, and it can be more than one, that we want to open up. And if to open it up, we incur an initial fixed cost. So to use it at all, we incur a fixed cost, then the variable cost. And this is the cost of opening it up. So you can see that Wichita is the cheapest place to open. In Baltimore, because land's probably more expensive around Washington, D.C., it's more expensive. So, and then the same thing as before, we got to try to meet demand at each of these 6 locations. So I'm going to do the same strategy that we had before. I'm going to take this and I copy it down like that. And then I'm going to turn these all to zeros. Like that. I lost my formatting, but that's okay. That's not that important. We'll at least do that. And then I'm going to do my sum. This is the amount of things shipped out of Baltimore. And this is the amount shipped to Atlanta. I'm going to start this out just doing a basic transportation problem. So is my variable cost. These are my shipping costs. Which is these cost rates against the amount shipped. And now I'm going to build a basic transportation problem where I'm trying to minimize this by changing these 30 cells, and then I've got 2 sets of constraints. I can't exceed capacity, so all of these have to be less than or equal to my capacity, and then demand has to be met, so all of these have to be greater than or equal to my demand. So we'll start with that. And you can see Atlanta, Memphis ships to Atlanta, Baltimore ships to Boston, Memphis ships to Chicago, Cheyenne ships to Denver, Wichita ships to Omaha, Salt Lake City to Portland. So we're using all 5 locations, and we've met demand. But we haven't used all the capacity except for Memphis. Memphis, we used all of it. We actually used Memphis for 2 locations. However, now I've got to add these fixed costs. The cost of opening it up. So how I'm going to do this is the first thing I'm going to do is I'm going to add another set of variables, and I'm going to put right here. And these are going to be binary variables. So I'm going to take my solver and I'm going to add another set. So in addition to these, I'm going to add these additional 5. So these will be additional variables I want the model to decide. But the trick is that these 5 are going to have to be binary. So I add a constraint, and what I do is in the constraint, I say that those cells have to be binary. And that means they're going to be zeros and ones. So that's one thing I've done. Now my true capacity is no longer this, My capacity is this if it's open. So if it's open, then that's my capacity. So to get there, I'm going to take my capacity if it's open multiplied by an if it's open or not. And now when I go to my solver, this constraint is no longer referencing column I, it's going to reference column K, because that's my true capacity. This is only the capacity if it's open. So I modified that, and the last thing is that now I've got to add my fixed cost, which is the fixed cost multiplied by an if it's open or not. It is this cost multiplied by my 0 ones. And that's my total cost. So back to my solver. I started with the transportation problem, and now I've got to take this. This becomes what I try to minimize now. And I've got two sets of variables. I've got my from tos and my yes noses. I've got my meet demand, I can't exceed capacity, and then I also have binary still leave the simplex, and now I solve this. And it's really cool. Look at this. I opened up 3 plants. I opened up Baltimore, Cheyenne, and Memphis. I did not open up Salt Lake City or Wichita. And the important part of that is that Wichita's not shipping anything, and Salt Lake City is not shipping anything. So I've now combined a facility location and a transportation problem. Thanks.